Hello student of grade 11 applied maths. Today we'll do chapter 13 limits and derivative. Let us introduce limits. The limit of a function are the fundamental concept of a calculus. So this is the basic concept of the calculus, because in calculus we have lots of concept, and to know all the concept you have to know limits. Limit is used to examine the behavior of a function near a point but not at that point. So limits is applicable only in functions. Okay, we have different kind of function: polynomial function, trigonometric function, we have exponent function. So when we will do the sum, you'll come to understand the meaning of this. So this term is limit is used to examine the behavior of a function near to the point but not exactly on the point. Okay, now let us give an example to understand this statement, how they study the behavior. You have to know that if I put the value 3 here, this denominator will be 0 and it will be you will not be able to determine. So this we cannot do. So we have to do some algebra solution here. When we say x tends to 0 or x tends to 3, that means it is not equal to 3, it's approaching 3. Okay, it's approaching 3. So this x square minus 9, if you use factorize this 9, I can write 3 square. So this is in the form of a plus b, a minus b. So in place of x square minus 9, we can write x plus 3, x minus 3 divided by x minus 3. That means I can cancel this. I can get limit x tends to 3, x plus 3. Now let us check the right hand limit. Let us don't this is suppose x and fx means the value x plus 3. Suppose right hand limit towards the positive side. If I take any value in place of x nearest to 3, if I take 3.2, and if I add 3, it will become x plus 3. If I take x as 3.2, it will become 6.2. If I take x as 3.1, if I add 3.1 plus 3, it will become 6.1. So if I can take not exact value 3 but nearest to 3, I can take 3.01, I'll get 6.01. If I take 3.0001, I'll get 6.0001. It's like not exactly, as the limit is reaching towards the value 3, the fx value is also approaching towards 6. So the value of this limit, we can say that it will be 6. As the value of x is approaching 3, the value is also approaching 6. So we can take the value of this limit as 6. We can also check the limit by taking the, we can say left hand limit, by taking the value from the left side. Suppose this is x, this is fx. Suppose I take the value 2.8. So this is x plus 3. In place of x, if I take 2.8 plus 3 will become 5.8. If I take 2.9, it will become 5.9. If I take bigger number, 2.999, it will become 5.999. If I take more bigger value near, I'm not taking 3 but approaching 3. If I take 2.99999, this will also become 5.99, which is so we can say that as the value of the limit is reaching 3, 2.99 is approximately 3, the value is also reaching 6. 5.999 is equivalent to 6. So we can say that the value is 6. So right hand limit and left hand limit are equal. That means the limit exists. Okay. and we can find the value. Now while doing the limit, in some of the question you have to take, for right hand limit we take x tend to 3 positive, x plus 3, and for left hand limit we take limit x tends to 3 negative, x plus 3. It doesn't mean this is minus 3, it means left hand limit. This symbol implies left hand limit, this symbol implies right hand limit. So based on this concept, we are going to do this chapter. So you have to know that x tends to 3 means not exactly equal to 3, but it is approaching 3. So if it is approaching 3, we can say equivalent to 3, okay? It is approaching 5, we will say it is equivalent to 5, and we will solve the sum. So copy down this introduction. There are some algebra in the limit also. Suppose fx and gx are the two functions such that both limit exists, then limit of a constant term will be always constant. For example, if I say limit x tends to 5 and here constant is 11, the answer will be 11 only. Nothing will change. X tends to anything, constant will be constant only. In this situation, if plus is there, we can break the limit. We can write this as x tends to a fx plus limit x tends to a gx. If it is minus also no problem. We can say write limit x tends to a fx minus fx minus limit x tends to a gx. If it is product also no problem. Limit x tends to a fx into limit x tends to a gx. Divide also no problem. We can write limit x tends to a fx divided by limit. So the limit is for both. We can say that. If constant is given, constant you can write outside, and limit x tends to a can be written as limit fx. If it is any root also no problem. We can write the limit inside x tends to a fx. If it is power also no problem. We can write limit x tends to a fx. Power we can take common. So these are the algebra of the limits. You can just note it down. This is our theorems, okay? Just note it down. And here are some of the formula of the limits which you have to note it down. For the trigonometric function, limit x tends to 0, sin x by x, if you see, it will be 1 always. Limit x tends to 0, cos x is always 1. Limit x tends to 0, tan x by x is 1. And limit x tends to 0, inverse function, sin inverse x by x is also 1. This formula, if limit is in this form, x to the power n minus a to the power n, x minus a, then this is the formula. This is n, okay? N a n minus 1. We'll do the sum based on this also afterwards. This is limit x tends to 0 will be 1 plus x. 1 by x formula is e. E means exponent. For this also, for infinite also, it is for this and this, the value is e. Limit log, if you don't write the base also no problem, but limit log 1 plus x by x is log ae if there is a base. If there is no base, it will be 1. And limit x tends to 0, ax minus 1 by x is log a. Limit x tends to 0, e raised to x minus 1 by x is 1. This is formula, okay? Note it down. Limit x tends to 0, 1 plus x power m minus 1 by x is m. And limit x tends to infinity, log x by xm is 0. Please note down the formula. We'll do the exercise 13.1. Thank you.